Thanks everybody for coming along tonight, listen to my presentation, and thanks to Simon for inviting me along. And I'd like to tell you about my company Picsea and a little bit about possible development of Internet of Things at sea. So we're going to talk about me and what I'm all about, and how the Internet of Things can be applied to the ocean, communications at sea and under the sea and how that works, and how you navigate in the sea. How Picsea is different from anything else that's available at the moment, our plan, and hopefully how you guys can get involved. So this is me doing the stupid picture. I'm an underwater robotics engineer. I've got an MSc in computer vision and robotics. I worked for the last 5 years at the University of Sydney, developing, deploying, maintaining underwater vehicles, and collecting the data and distributing it to clients. I'm now working full-time on my Picsea project. So Internet of Things, Simon said, hey, do you want to do a presentation at Internet of Things Scotland? And I was like, oh great, what's that? That's like we have a fridge, right? And then it orders your shopping automatically. And I was like, so I went home and I went into Wikipedia and I was like, okay, Internet of Things, and how am I going to stick this together with my robotics at the sea? So I took this picture from Wikipedia site, as all great researchers do, and it's all fitness and intelligent homes and security and all those sort of things. But just one thing about them: they're all based on the land. There you go. Did I miss a slide there? No, that's right. Okay, so communications at sea. Is there a slide missing there? No, okay, we'll keep going. Yeah. Okay. So it's gonna check it's the right file. Anyway, communications at sea is a very difficult thing. You need
The latest one that you sent me. Are you worried it's the wrong day?
yeah. I'll keep going anyway.
Do you want me to find the other one that you sent me?
No, is this the one from today?
Yeah.
Yeah. Okay. All right. Okay. Sorry, guys. So underwater, it's very difficult to talk to anything because basically the only option you have to do long-distance communications is to do acoustic communications. Over very short distances underwater, you can do optical communications, which you can get relatively high speeds. But also over very short distances, like about 10 meters, you'd be lucky to get that. So traditionally what you do when you collect data from especially underneath the sea is you put something in the water, a sensor, a robot, some other vehicle, and you bring the device up and you bring it onto the boat, then you plug it in, then load it onto a hard drive, you take the boat to the port, then you plug that into your computer at home or in your office, and then you get it onto the internet. So with intelligent devices, we're looking at in the sea, we're talking about getting rid of the boats and talking about getting rid of people involved. So what are your other options? So you can send data by radio satellites, by radio to satellites or to land. You can have cables. On the seafloor, and then you can get that cabled up to the land, but it's very expensive, and obviously your sensors are only then in one place. Navigation is another issue at sea because as soon as you go under the water, you don't have any GPS anymore. So, what do you have to do? And it's no good getting data out of the sea if you don't know where you got it from, because it's completely useless. So, when you go into the water, what have you got? You've got a compass, gyroscopes. This is a special kind of sensor called a Doppler velocity log. This you can use to, it's basically a giant 3D optical mouse that works with acoustics. So as you move along, it gives you X, Y, Z displacements, and you can integrate this into a bigger model. And the same for an accelerometer, you get the same sort of data and you integrate it over time. Problem with these is all the errors grow exponentially with time, and you become uncertain of your position. Depth is very easy because you just measure the pressure, and you know when it's this pressure at a certain depth, you have to account for tides, but it's relatively easy. And also we have visual odometry, so we take a series of images. If you have cameras that can see anything, once you're close to the bottom, and you can use this to build into your model, stick it into a Cohen filter, and get an accurate navigation solution. So which data do we want to get from the seas? Geophysical, so sonar, this is what you use to build up the kind of maps that we have, pretty much of all of the ocean. Visual imaging, which is very difficult to get because you have to go to the bottom of the sea. You have a very small viewpoint, and you need a lot of images to do this. You can do coring samples, so where you physically send down an apple corer, take an apple and have a core end of the apple of the bottom of the sea, and then have a look what's in that and infer some geotechnical information about that. Or you can do seismic surveying. So you create some impulse often from an explosion, and then you listen to the sound that comes back, and from this you can then reconstruct the shape of what's in the bottom of the sea and also subsurface. Environmental data, that's where I operate traditionally when I worked in the University of Sydney, and looking for things like temperature, turbidity, how difficult it is to see through the ocean, and from this you can apply biological aspects like how healthy is the ocean, and by analysing chemicals in the sea, what if there's any pollution, and how likely is it things are likely to survive, and the way they interact with each other. Acoustic data is a particularly interesting one for Internet of Things. So there's a lot of this kind of thing set up where you have just a bunch of microphones or hydrophones in the sea, and they listen in networks, and from this you can see where marine mammals are, and also detect like seismic activity from tectonic plates moving and things like that. Who wants to see ocean data? So explorers, I think it's normally said that we know more about the surface of the moon than we know about the bottom of the sea. So there's a huge amount of stuff to be explored there. Prospectors, so anybody who wants to exploit a resource from the sea, whether it be oil, fishing, and mining. Subsea mining's coming into the domain now. And if you want to do that, you also need resource management. So monitoring the environmental effects of an oil company, like making fisheries work properly, ensuring that they're not getting overfished, and that the environment that the fish have to breed in are appropriately managed. Science, I mean, there's all sorts of science in the sea, but if you've ever been on a marine research vessel, you always go and find something that nobody's ever found before. Infrastructure inspections, that's becoming more and more important with infrastructure like offshore wind coming into play. Pipelines, they all need periodic inspection along with cables under the sea, and if you don't, then you got chances of not detecting something that could cause like a pipe rupture or data loss over an international cable. And defense, there's a lot of people that are trying to hide things in the sea, and there's a lot of people that are trying to see what people are trying to hide in the sea. So obviously that's a very interesting thing. I got it's me doing a bit of a survey there. There's some scallop beds. That was a project I worked on. That was pretty cool. That's methane cathrate. That's the methane deposits that you can mine and turn into fuel. And that's a pipeline inspection. So it's got my pirate ship this time on this version of the slides, but so I think we've covered that already. And navigation instruments. And yeah. And so I start to talk about Picsea now. Sorry for running late, I got a bit confused there. So yeah, we're working on developing a low-cost autonomous underwater vehicle, a robot you can put in the sea that is used to build up 3D maps of the bottom of the sea. And this is very expensive at the moment, so what I want to do is move the worlds of the oceans to like the few organizations that can afford to commission this data at great expense to the many that need and want to explore it and analyze that data. And yeah, just explore, manage, protect the resources that are there, and just generally gain the knowledge that can be accessed. So how are we different? Yeah, so it's tackling the two main problems of collecting this sort of data. Low cost, or completely changes the way that people think about the design of underwater robots and how they're deployed. And basically we're going to end up at the start of the project being able to reduce the cost of collecting this sort of data by about 10. And the later stages of the project is going to be into the thousands. And it's going to be much faster. So we did a bit of an idea like, okay, if we wanted to get a square kilometer, how much would it cost and how long would it take? With our stage 1, 2 prototypes, we're looking at 200,000 US to collect 1 square kilometer with our technology, and you'd be able to do that in about 5 days with a conventional vessel and one large AUV like this one. And it would take about 40 days and cost about $2 million. So as I said, we're talking about creating this easily deployable underwater robot, and the aim is to be able to collect really large scale Google Maps like photorealistic maps. So it'd just be like you go on your computer and you can see, just like you can see the centre of Edinburgh on Google Maps. And so it's always going to be employed individually. So like I want to go and see what's in the sea there, and you can chuck it in and get it back. And but it's also designed to be really tough. So you can chuck it out of a moving boat or an aeroplane and just let it do its stuff. Yeah. So we're also moving towards being perpetually deployed. So leaving it in the sea. We have solar panels, so it can float around, charge itself up. And yeah, then you can leave it in the sea, and they don't need any people, any boats in the sea, and we can just opportunistically scavenge data. And then finally, we're going to work up to using really large networks of these vehicles. Yeah, it's starting off in tens, then hundreds, then thousands, and possibly into over the millions, and using Internet of Things and satellite technology that's coming out in the next couple of years, and build this into really large scale maps, so you really truly be able to get towards Google Maps underwater. So how are we going to do this? Well, we're working on stage 1 at the moment, produce 150 meter rated AUV, and it's going to cost about 100 times less than anything that's really available on the market at the moment. And yeah, it's just to use individual. Then we're going to start to build these robots together, develop some swarm and AI technology, start them working collectively together and try and find some nice applications and get some really good data sets. Stage 3, so then we're going to start really focusing on making sure that we can make this work at the bottom of the sea, which is one of the harshest environments you can get. Talking 12,000 meters is possible. So, but one of the best things about the design that we have is that there's not a very big technology gap between the 150 meter version and the full ocean depth version. And then finally, for stage 4, we're trying to find somebody who can help us pay to do really large scale surveys. And my real dream is to be able to capture an image of all of the seafloor of the world, which is, I know, very big, but probably a bit crazy. So where are we at? We're at stage 1 prototype. I'm currently building over at Summerhall. This time we should have it in the water at the end of the year. And I'm currently also working on attracting investors and people to work with me. We have Julian here who's started to work with me too, and I've been talking with Simon a bit, and I'm also, any of you guys that are interested in becoming part of this or having a chat about it, these are some of the people that, you know, could really help us along at the moment. So yeah, software engineers, people who work with robotics, AI, anybody that's got some time to dedicate to doing some hydrodynamic modeling, computer vision and SLAM, simultaneous localization and mapping, to do both sides, so with to do with the navigation and also to do with reconstructing the images at the end and building really efficient models to get those reassembled. And anybody who's good at attracting money, or anybody who's got any money they would like to invest, would certainly be interested to hear from you as well. Thanks very much for listening. Sorry about the mix-up earlier. And